Hello everyone. I have asked the organizers if I was allowed to record my presentation and post it on YouTube, and they said it is okay as long as nobody in the audience appears. So don't appear in front of this camera, otherwise I will not be able to post it on YouTube later. But I'm Davi. I'm one of the founders of PyFop, which is a startup that gets its name from our web application, PyFop. And it is a toolbox for doing mathematical optimization online. Our goal is to provide a similar experience of that you get from using tools like Google Docs, Google Sheets, Overleaf. So you enter it, access it online, you do it, your work, everything online. You don't have to install anything, you don't have to download anything. You get a complete environment online. So in order to support mathematical programming in a web environment, we provide a lot of integration, providing a online ID that is built for collaboration, so multiple people can work together in the same project, just like the tools that I have mentioned. It provides machine resources, so you can connect your own machine. If you have a powerful computer that you want to use remotely, you can use Python for that. You can integrate for Google Sheets. You can use it for free, as long as you are content with our free features. And one of the free features that we have is integration with the NEOS solvers, so you can access Simplex, Gurobi. If you are doing research or you are working in education, you can use it for free, these features. So one of the main features for modelers in our web application is the ability to run solvers remotely through what we call optimization servers, which allows PyFop to access allows you to access PyFop from, say, your laptops and run the model that you are working on your laptop in another machine. That would be this over here on the right. So you offload the solving of your model to another machine, and it is PyFop provides you these features. This single feature solves so many problems and has so many practical applications that I thought it was worth it to give a talk about remote solver execution and how PyFop can help you with that. So let me start by pointing out two main common reasons why you would want to execute solvers remotely in the first place. So the first main reason is that, as I'm sure you are all aware, many optimization problems are computationally expensive. So they often require much more memory and processing power than you have in your average laptops. So you often, in this case, need to offload your execution to another machine. And the second use case is when you have a single machine with the solvers tied to that machine. It is a common arrangement in solvers vendors that they set a constraint in which you can only install a solver in that particular machine, and you have to somehow use that machine. And you cannot install it or use it from anywhere else. So how would you achieve that remote solver execution without PyFop? The first way that we have traditionally used is to use SSH to do the job. So you access the remote machine via SSH tools. If you are Windows, you use PuTTY or FileZilla, and then you transfer your files over, and then you access the machine, and then you execute your command in that machine, and you do the work that way. It works, but it's not fun. It is too low level, in my opinion, and that's the method I used when I first started doing mathematical research. But it can be difficult, especially for beginners. So I always felt that should be an easier way to do that, and that's one of the reasons why we have developed PyFop. The second way that you'd using what I am calling a solver-specific feature. So some solvers, they have a feature in which you install your solver in your laptop and you install the same solver in the remote machine where you want to use it, and then when you call your solver on your laptop, it actually offloads the execution to that other computer, and you can achieve remote solver execution in that way. There are some variations across different solvers and across different systems, but that is the general idea behind all of those features. This method can be used in some situations, but it has some drawbacks. The first one is not all solvers provide that feature. So if you are using an open source solver, for instance, you will probably have to switch to a commercial solver that actually provides this feature. The second reason is the solver vendors that do offer this option can charge. You will probably have to pay a little extra that may or may not be within your budget. And third, the remainder of your program still gets executed locally. And this is an important point because it is a partial offload of the execution. So if you have a more complex program, which are getting more common nowadays, that modelers are integrating different techniques, so they are not only doing mathematical modeling, but they are mixing in some machine learning, some other type of prescriptive and predictive analytics, and then you want to offload the whole program to another machine, and you don't have you don't want to run it on your machine, the whole program, not just the mathematical optimization part of it. Now, Python provides an alternative way, which is what I'm going to show you in these next few slides. To start off, I know most of you probably never heard of this tool, so I'm going to give you an overview of how do you use Python. This is our online web IDE. On the far left, you can see the files of my project. On the center left, I have the code editor, in which I can modify the source files. And then on the right, I have a terminal. It is a special kind of terminal because the commands that I run in this terminal are not actually executed in the machine that you are using, but are actually offloaded to another computer. So in this example.py that I have over here would run in the optimization server that I am connected to. This optimization server is shown on the top of the terminal, and you can have multiple ones. You just have to select which one you want to upload to your program, and then it will automatically do that. You don't have to worry about file synchronization. It will run, and if your program happens to generate some files like short files or some kind of log files, they will also be retrieved when the execution ends, and then you will have everything working like you would expect it to work if you were using your desktop for the job. It supports parallel execution, so you just open up a new terminal and run a new command, and you can safely shut down your computer. You can leave it running for hours or even days, and then you get back to see the results later with no problem at all. Which does not happen when you happen to use some of the options that I have mentioned, the solver mechanism, because you usually have to keep running your client within your laptop, and you can't stop that execution. You have to run it to the end, and you have to wait for it to finish. You cannot turn it off or anything. Yeah, so this is an overview of your workflow when you are using Python. And now I'm going to talk about the advantages of using this alternative that I'm presenting to you. First of all, Python is solver and language independent. it is software and the language independent. So it works with AMPL, OPL, Moselle, Python, C, C++, Ruby, C++, Express, Hive, Stitch, and so on. You can imagine other tools being included here as well. The only thing that I would mention is that we are integrating new modeling languages as the demand comes. So let's say you work with Julia, then you say to me, and then I will provide this new environment. I will add this support in our web application. So secondly, it offloads the entire program execution. Like I just said, you can forget about it, run your command and come back later to see the results. And it offloads the entire execution. It is not just for mathematical modeling. So if you have a more complex system, more sophisticated system, you can offload the entire program. The third point here is that PyFOP is a new way of sharing resources, sharing machine resources and sharing software resources. So a single optimization server can be used by multiple people. So you can install your software and modeling systems in a single machine, which is the optimization server that I have talked about. And then multiple people can use that machine. So if you have, for instance, a license that you have to install that machine and it's tied together to that machine, you can have multiple people accessing that machine. And the fourth point is that we provide optimization servers if you want. So if you don't want to worry about configuring an optimization server, maintaining it, you have this option on web or web platform. Those are some general points, and now I'm going to talk about 4 use cases in which those points are more clearly seen. So first of all, PyFOP is a great tool to be used in universities' operations research courses. In fact, that's how we have started 4 years ago. We have adopted PyFOP, not adopted, but developed PyFOP with the purpose of modernizing and facilitating the workflow of teachers and students in our university, which you can see in the screen, which is Universidade Federal de Minas Gerais in Brazil. And we have developed it with this purpose. So multiple people can use the same resources concentrated in a single machine, and you can share the resources, the computer resources and whatnot. And this makes a huge difference in the workflow. It is very agile because the teacher doesn't have to worry about troubleshooting, installation on different computers. Some people are using Mac, some people are using Linux. Whatever, you only have to access it in the web browser, and everything will work just fine. And there are also many other features that you can learn about that makes PyFOP easier to use in this context of education. But I'm going to go ahead to the second point that I have over here, this a second use case, which is for researchers and research groups. So PyFOP being a web application just like Google Docs and Overleaf, you can have multiple co-authors working in the same project. They can work together, they can work in real time, no problem, and they can share their research models, tests, and benchmarks online in a way that makes it easier for readers to see the results that they are presenting in their paper. It allows for more transparency and reproducibility of the results, because they will be accessing the results online and they will be able to run the models that you are showing and reproduce results with no problem, no setting up or anything. Third use case, PyFOP as a model code submission platform. So a possible use case is that use PyFOP for submitting your code to a journal or an editor so they can review it, just like I said, mentioned in the research part. So you can use Bible as a platform for submitting your code to other journals. So some journals do technical review, so they may request you to share your code with them. You can do that on Bible. They can run it, they can reproduce it, they can test it, and whatnot. Last use case that I have over here. We are taking steps to enable users to call their models and heuristics from other applications via a REST API. It is an experimental feature that we are calling BiFoc functions, which essentially turns your optimization models into a web service. This is a screenshot of a demo vehicle routing problem web app of our consulting company, which is a completely different web application from Bifoc, but it uses Bifoc as its back end, let's say. So it uses Bifoc functions to offload whatever input the user puts in the application that we have developed, and then the results can be retrieved just fine after the execution is finished. And you can let me know if you want to learn more about this feature, because it is an experimental feature, so you will not be able to learn much from what we have on our website. But I'm happy to give you more information about that. That's it for me today. You can learn more on our website. You can try Bifoc for free, like I had said, so go check it out. And I believe we have time for some questions, but you can also contact me in this email over here, and you can find us actually in the social media. Thank you very much.